so now we're going to move on to the last two talks in this session. And the first one is by Tracy Becker. And Tracy's going to talk to us about the science in STEAM, the role of the scientist in the development of outreach and education materials for SSERVI class, the class team run by Dan Britt at the University of Florida. Thank you very much, Tracy.
Thank you.
I'll give you a 2-minute warning.
Okay, great. Lower these a little bit. Hi, everyone. Okay, so thanks for inviting me to give a talk on this subject. I think it's a testimony to, as what everyone else has already been saying about this, where this group actually leads the way in education, in the desire to push forward, teach the next generation, and reach to the public and give them the exciting information about science and exploration that everyone in this group is doing. So the next slide, please. As was said, I am a representative from class at the University of Central Florida, even though I've moved on now to Southwest Research Institute in San Antonio. This effort is actually a combined education and public outreach effort between class and SEED, which is hosted at Brown and MIT with Carly Peters, and UCF is run by, the node is run by Dan Britt. And the education and outreach lead that kind of combine these two nodes to make this amazing program that we're developing is Cass Runyon, and she is a poster, and Cindy Hall, and they have a poster this week as well, so you can check that out for more details on the actual what we're doing. Next slide, please. So I will start a little bit with what we're actually doing. So we have a couple of goals with this outreach program, and I want to actually make it clear that I've been involved in this now for 4 years. So this program has been a long, big development of a really serious effort to do formal education curricula, informal education opportunities such as at museums, at libraries, at after-school programs, so that we can really reach out to as many people as we possibly can in an effective way. The idea is to infuse STEM with art, making it STEAM. So if you're probably hearing that term more and more often, it's a great way to get all learners involved, so not just people that maybe feel like they only like art or don't like science for whatever reason. This is a way we can actually tie everything together, and everyone can have an opportunity to express themselves in an artistic way and bring them into the science fold as well. And the main thing, one of the coolest parts about this program is the effort that's been made to incorporate all learners, including those with some sort of disability. So if you're hearing impaired or visually impaired, you also have opportunities. So I'm sure some of you have seen this release that came out recently where Cass and Cindy and a group of other teachers developed these books for visually impaired people to be a part of the solar eclipse and to actually see it by feeling it. There's also these textile books that have been created by that group as well. And so they're actually really being able to incorporate a lot of our, the activities we include have different options for those people who may not be able to experience the solar system the way that everyone who doesn't have any of these impairments gets to experience it. So it's a really awesome aspect of what we're doing. Next slide, please. So what are we doing? So as I've already said, we're basically in the process of developing this large curriculum. It's an interdisciplinary curriculum that will actually incorporate art, math, science, engineering, ELA, the language arts programs. This is an actual body of text that we will give to teachers that will have different assignments, different activities over the course of several weeks. I forget exactly how many, 6 to 8 weeks. Where you actually have all these opportunities to have all these different courses be involved in the exploration of space. So it's kind of this way of incorporating all of the classes, all of the ideas into this one program, which I think is fantastic, and it really actually intertwines all of these different subject areas. Now, this is such a big endeavor and such a unique thing that one of the women who was talking about it actually like teared up at how excited she was by being able to present this to teachers, because it's really what people like to talk about all the time, interdisciplinary, you know, et cetera, et cetera. This is actually doing it in a way that we think is going to work really well. So that's the kind of the big bulk of it. We're also using that as a launching point, everything we made for the formal curriculum into informal activities. So this again will go for libraries, after-school programs, summer camps, Girl Scout events, Boy Scout events, whatever people want to take from it. And we'll have different things, and we'll indicate the length of time it's required to do those programs, what level, what age level, et cetera, et cetera. So we have all these different ways to get this information out, and it's all based on what the science is being done and the exploration efforts being done by the seed and class nodes. Again, incorporating the arts, and again, making it accessible to all learners, including those with any kind of impairment or disability. Next slide. So who are we? Basically, what's been done, which is really what's making this so successful, is that we're incorporating people from all different aspects of this learning process. So we have obviously formal educators, so teachers at all levels, but mostly middle school and high school. Informal educators, so again, these are people who maybe run programs at museums, or there are people who work at like the library of a school that maybe is for students with less ability to stay in the classroom. They have some issues at home, or et cetera, et cetera. They end up in these kind of schools. We actually have a librarian who works at one of those schools who can, has a different idea of what her students need compared to other people's students. Curriculum develop experts, tying everything together for us. Next gen standards, so these are the standards that are kind of national, that not every state has to adapt, but most states have adapted. So it's a way that the teachers can say, all right, yes, I've checked off 4.1.1. We're addressing this concept. So that all gets incorporated. So it's super easy for the teachers. Artists, actual artists, visual artists, people who are drawing, people who use computers to create art, storytellers. We have a few storytellers on board, which is a very interesting, unique way to actually communicate the science in a fun way that maybe sticks around. Storytelling is one of the oldest ways of passing along information. So this is actually incorporated into the curriculum. And then scientists. So I'm not the only scientist. There are a few of us. But we are there, obviously, to make sure that the science of what's being done here is accurately included into the material. So next slide. So all the pictures that you're seeing actually are from these events that we've had. So we've had these multiple workshops over the last few years that we can progress these ideas and concepts. On the top, you can see Eric designing art as the storyteller tells a story of this object in the Kuiper Belt that comes into the inner solar system. And he's drawing as they're telling this story. So it's kind of that combination of everything. This on the bottom, we had one of the workshops was hosted at UCF, and so this is formal educators that were invited to participate and see how the program was going and how it would be used in their own classrooms, in addition to the core group. We did some tours of UCF labs, so they got to experience kind of firsthand what science it is that they're trying to communicate to everybody. Okay, next slide. So the curriculum itself, I'll let Cass explain more at her poster. She's way more knowledgeable about all the pedagogy that's being included, but we are trying to do all these really cool things. And again, it's exploration and science focused. So the idea is we need to go to an asteroid. How do we get there? why are we going there? What parts are we going to go there, and why? So it's the science and the engineering. They have to design in groups that will work as engineers, scientists, and again, it'll extend over months or weeks. It's not just a one-day, one-off program. This is a long-term thing where they'll read material about the asteroids, use that information to decide why they want to go to this particular asteroid or particular region on that asteroid. Then they design some sort of scooper or something to collect the material. So they're actually fully involved and invested in what this mission would be like. Yeah, so a lot more at Cass's poster if you want to ask a lot more about that. So next slide. Okay, so what's my role? That was the point of this whole talk. As the scientist, or one of the scientists at least, I'm providing real-time feedback. So I'm there while they're developing the ideas, developing the curriculum, and I can say, oh no, like that's not really what we're trying to do. That can lead itself to misconceptions or poor ideas that sometimes we all know get infiltrated into the curriculum. basically, we can also ensure that the science drives the lesson plan. So it's not just what's the easiest or maybe what's just the cool fact that some of the teachers might know about. This is the general science that we want to be communicated to the students, to the public. And I think that's one of the most important parts that we can do as scientists by getting involved in these programs. We can actually kind of control, we understand how it's being disseminated, and we can control more of what's being disseminated to the public. Where I act as the liaison, basically, for the primary sources. So those of you who are in class in SEED, you can expect to be requested to provide some written materials in the near future. What I found, actually, was some of these articles that you'd think are from good sources, they're being pulled from places like IOP Science and other places, and they were just really not the best resources to be given to students. So it's been nice being involved in that way, where I can catch these things and say, oh, no, like, let's just do a real primary source. We'll have a scientist actually write up what they're doing in a way that's accessible to the students. And if that can't be done, we give it to the teachers, who will rewrite it slightly in a way that will be accessible to their students. Yeah, and again, catch any misconceptions. But also, as a scientist, I'm learning from others. I'm actually understanding more about what are the new techniques to teach science in the classroom. It's not the same as it was when I was growing up. It really is this hands-on approach, this way of becoming immersed in it. It's not any more memorization about science. You don't name all the different types of classes of animals and things like that. You experience it, and then you kind of learn the general idea afterwards. And so I think we can all agree there are times where we feel that maybe a lot of the public isn't as scientifically literate or understanding as we'd want. So hopefully these kind of new techniques and new approaches are going to help us get to that next level of having everyone be much more aware of the science and understanding it better at first take. Again, these state-of-the-art education practices, and as the scientist, as I get to learn from them, I can also I can learn how this science gets interpreted and disseminated to people. And also, everyone's a different learner, so you have different types of classrooms, different types of audiences, and that's kind of one of the best parts that I get to learn about, is how do you communicate this to this age group, or this group of students who may not be in the same kind of education level that they might be supposed to be at their age, depending on where they've grown up, et cetera. And so it's really nice, and we have this collection of people. So again, these are pictures. So there's Kay Chipola, many of you probably know her, being a storyteller and telling a story about space exploration. I learned about this Globe initiative that NASA's doing, which is pretty cool. You can download it on your phone, and it's an app that you can go outside and track where the sun is and the clouds are, and NASA's using all that data, so it's citizen science. It's really great. So that's what they're doing on the beach there. And then that's just us hard at work, getting our curriculum developed. Next slide, please. So I want to advocate for this kind of a program, this long-term, interdisciplinary type program, interactive outreach. It's really successful. One of the benefits you have from doing it for so long is that we're all interacting with each other. We all know each other's strengths. We all respect each other. And we've developed this relationship that enables us to really make good progress quickly every time we meet. We get this continual feedback between the scientists and the teachers. So it's not just me kind of creating a program, or one of you guys just creating a program and hoping that that's the best way to teach it to the kids. This is continual feedback. I might have an idea and they say, oh, that's good, but let's tweak it a little bit, because the kids won't understand it in that way. And then when they tweak it, I'm ensuring that they've tweaked it not such that the merit has been lost in any way when they tweaked it. So that continual feedback is really what's going to make this program so successful. It's a real way, again, to incorporate the science, new science, up-to-date science into these curricula and get this out to all the kids and get them excited about the idea of exploration in space. Yeah, it's unique. It's going to be useful. It's robust. It's a big program, and you can't create these on these kind of small grants. This is a 5-year effort utilizing all these different people, and it's kind of one of a kind, I think. So next slide. If I've inspired you to partake in any way in this idea of getting this information out there, we do want to bring this beyond just the formal curriculum, informal curriculum. We want to bring this to the current age. So we're doing things like short video podcasts, kind of things that will get that the kids will have access to. Also, like an Ask Me Anything on Reddit type feature, where we'd ask maybe a scientist to be in charge of answering a bunch of questions about their science. So if you're interested in being a part of this, any SSERVI node, you can email me at tbecker@swery.edu. Thank you.